Hey guys, and welcome back. Today we are continuing our lesson in changes in matter. So we're talking about matter still, and today we're going to be able to identify the difference between physical and chemical changes. So let's go ahead and jump right into it. So before we can talk about the difference between a physical and a chemical change, we first have to be able to define physical and chemical properties. So let's start with the physical properties. A physical property can be observed and measured without changing a sample's composition. So these are often used to identify a substance. They can include things like melting point, boiling point, density, pH, color, odor, taste. Also, the mass and the volume would also be physical properties. So when you describe the physical property of something, you're basically using your senses or some type of measurement tool to describe the object or the substance. So, for example, let's say I gave you a glass of water and I asked you to describe it to me, and I asked you to tell me some of its physical properties. Well, you could always start with your senses. You could tell me, well, it's clear, right? So it's colorless. It doesn't typically have an odor unless it's like contaminated in some way. If you were to taste it, it's pretty tasteless. Some water you can taste the minerals in it, but for the most part it's tasteless. If I were to give you a pH strip, you could measure the pH, which is just how acidic it is. Distilled water should be a pH of 7, which is neutral. All of those are ways you can identify a substance based on its physical properties. Now, there are two different types of physical properties, intensive and extensive. Extensive are dependent upon the amount of the substance present. So examples of this would be like mass, length, and volume. So these things can change based on if you add or take away the substance. So if I gave you that glass of water and it starts halfway full, let's say it has like 120 mils of water in it, and I come around and I pour more water into your glass, it's still water. The property of water, the chemical property hasn't changed, but now instead of having 120 mils, you might have 240 mils. So those things can change in terms of the amount of the substance there. On the other hand, an intensive physical property does not change based on the amount of the substance present. So these are things like density, pH, melting point, boiling point. So for example, that distilled water that we talked about, the pH was 7, right? Because it's neutral, it's distilled. If you had half a glass of water, the pH would be 7. If I added more water to it, it's not going to change the pH. We could still test it and it would still be 7. So intensive physical properties, it doesn't matter how much of the substance there is, it's always going to be the same. Now let's talk about chemical properties. Chemical properties are not usually visible, and a change in matter occurs when we're talking about chemical properties. They can only be seen when there's a chemical reaction, and examples include rust, burning, and the ability to react in a chemical reaction. So if you've ever had like a bicycle that you've left outside, it's gotten wet, and over time you've seen rust form, burning wood or burning paper, those are chemical properties because you're changing the substance on a chemical level. So we're going to stop and we're going to do a really quick check for understanding. So what I want you to do is go ahead and pause here, and I want you to classify each of the following statements as a physical property or a chemical property. So pause the video and write down these scenarios, so 1 through 5, and then classify as a physical or a chemical property. Then unpause and we'll go over the answers here in just a minute. Alrighty, so hopefully you've paused and done that in your notebook. So one says iron and oxygen form rust. So this is a chemical reaction. So the iron and the oxygen are reacting together to form rust. Typically you can notice a chemical change by a change in color. So this would be a chemical property. So that change on a chemical level, that's going to be a chemical property. 2 says iron is denser than aluminum. Density is a physical property. So the density of iron, it doesn't matter how much iron you have, it's always the same. Aluminum, doesn't matter how much aluminum there is, the density of aluminum is always the same. Iron will always be more dense than aluminum. That's a physical property. You're not changing anything about the chemical composition of the iron or the aluminum. We're just talking about the physical density of those substances. 3 says magnesium burns brightly when ignited. That's a combustion reaction. So that would be a chemical property. 4 says oil and water do not mix. That's again going to be based on density. So that's going to be a physical property. And then 5, mercury melting at negative 39 degrees Celsius. That again is going to be a physical property because that's a melting point. So if it's negative 39 degrees Celsius and mercury is melting, mercury is still mercury. It's just now in a melted form. So that's a physical property. So all matter, regardless of state, undergoes physical and or chemical changes. These changes can be microscopic or macroscopic. Now, microscopic would be like the chemical level, something is changing about the chemical compounds. Macroscopic, macro means large, that means you could see it. So you could see the change happening. All right, so let's talk about physical changes. A physical change is a change that alters a substance without changing its composition. So it can change the property, but not its chemical nature. Typically, a physical change could be reversed or undone. And examples of this include cutting paper, molding clay, melting ice, breaking glass, freezing juice, etc. So we have a picture here of a little aluminum can. So it's an orange soda can that it's been crushed down. The can itself is still aluminum. There's nothing different about the chemical property of the can. However, the physical property has been changed because we crushed it down. So you've just changed something about the physical appearance of the substance, but on a chemical level, it's still just aluminum, just in a different shape. So that would be a physical change. A chemical change is a process that involves one or more substances changing into a new substance. So examples would include milk souring, iron nails rusting, so rust is a chemical reaction, a match being lit, so any kind of combustion, any kind of burning is going to be a chemical change, silver tarnishing, food being digested, all of that is a chemical change. So you're changing something about the chemical composition of the substance. Here are the indicators of a chemical change, because today you guys are going to have to do a checkpoint where you go through and identify whether something is a chemical or a physical change. So ask yourself if one of these things is happening, and if the answer is yes, then you have a chemical change. So is a gas forming? So is there a reaction and some kind of gas is being formed? The formation of a precipitate is just a solid. So like if you mix two chemicals together and you get a solid that comes out of it, then that would be the indication that a chemical change has occurred. Is there a change in temperature, or is there a change in the energy? Is there a color change? So have you seen something go from one color to another? And is there any kind of odor or smell produced? If you can answer yes to one of those or multiple of those, then a chemical change has occurred. All right, so we're going to do one more check for understanding. Here are 4 scenarios, and just before, when we were identifying chemical and physical properties, I want you to go ahead and pause, write these down, and then just next to them, go ahead and see if you can identify them as a physical or a chemical change. Then when you're ready, replay the video or play the video, and we'll be able to check them together. Okay. All right. Hopefully you had the opportunity to pause. But let's go through these and identify them as chemical or physical change and why that is. So one says water is heated and changed to steam. So water is heated and changed to steam. This one can be a little bit tricky, but this one is going to be a physical change. Okay. So here we're going from a liquid to a gas. So water is going from liquid form into a gaseous form, steam or water vapor, but it's still water. Water vapor is still water, just in a gaseous form. So it's still H2O. And if you were to condense it, it could go right back into a liquid. So remember, physical changes can be reversed. So that's actually a part of your water cycle. If you remember from earth science, water gets evaporated into the atmosphere, then turns back to rain as it's condensed into clouds and falls back to the ground. So that is a physical change. So water can go from water vapor back into liquid water. Because there's no change on a chemical level, whether it's liquid or gas, it's still H2O. It's a physical change. 2, a match burns. That's going to be a chemical change. So anytime you have a burning or a combustion reaction, that will be a chemical change. Number 3, silver tarnishing. So if we think about a brand new piece of silver that's shiny and beautiful, over years, tarnishing just means it dulls a little bit. So the metal itself looks duller. Maybe it has some kind of darker gray spots on it. That's going to be a chemical change, because remember, one of the indications of a chemical change is a change in color. So when we see that silver tarnishes, we're seeing a change in the color. That's an indication that that metal on a chemical level has been changed somehow, and that change in color lets us know it's a chemical change. And then last, but certainly not least, number 4, paper being cut into smaller pieces. That's going to be a physical change, okay? You're not changing anything about the paper. The paper is still paper. The chemical composition of the paper is the same. You're just putting it into smaller pieces. It's the same idea as the aluminum can that we saw in the earlier slide that was just smushed down. It looks different. The physical properties have changed. It's gone from being one large piece of paper to a smaller piece, but it's still on a chemical level. It's still the same paper. So cutting it into smaller pieces, it changes the physical properties, and it's a physical change, but the paper itself is still paper, so it's not a chemical change. All right, so you guys today are going to do a quick checkup on Canvas to identify the difference between chemical and physical changes. You've got some multiple attempts on the assignment, so if you don't get it the first time, you can attempt it a couple more times so that we really understand the difference between these. But if you need help, always remember you can reach out and I will be more than happy to help you. So that's it for today. I hope you guys have a great day, and I'll catch you in the next lesson. Bye, guys.